I wanted to give a little bit of an overview of how one of the implementation projects that we have in Prpl has actually evolved over the last 12 months, namely prplWrt. And just talk a little bit, I'm going to try and keep this very short, and then hopefully the demo setup here will allow us to show a little bit on what that is, and then we will catch up with the schedule here, because the next item is very important. It says cake, so I'll try and be very quick with that. So going back 12 months, by the way, who here in the room was actually in Lisbon with us last year? That's good, half, okay. So we have lots of new visitors here. That's very nice. So last year I went on stage and I basically talked about how we relaunched prplWrt as an effort, or revitalized, or whichever way you want to look at it. And that's one of the slides that I showed, where just to outline the motivation, where it comes from, and then how router stacks at that point weren't able to deliver, and how this is what product development looks like in a lot of ISPs, right, where you have repeated development, and what we wanted to do was come to one platform. And for that, we had this outline where we took the community project as the center, and then would add on top things to basically build a complete stack, which in the end would allow you to combine software from various vendors into one build. And that is what we demonstrated last year, where 3 vendors actually came together to build one common software image, which we then demonstrated with end-to-end DSL right to Q multicast. Right? We showed Olaf, we showed multicast. So that was quite impressive. At least I thought that was quite impressive, how quickly that all happened once we aligned on how the integration would work. And then we also had this goal of establishing Prpl and the prplWrt project as a project that sits between the corporate teams that have the pressure of delivering under time-to-market constraints, and then also the quality that is expected by the upstream communities. That was the goal that we had last year going forward. And I think we've actually come quite a long way over the last 12 months, even if you hear sometimes people look at the GitLab and they see the code that's in there and they say, well, that's not a lot of code. I don't think that we lack lines of code in the industry. That is not the problem that we have. The problem that we have is that there is a limited alignment how those lines of code get used, and how you actually fit them together if they come from different sources. And that is what we're addressing with prplWrt. So if you take that apart, there are actually more. I used to have 4 components. Now there's actually become 6 components that I look at when I track the project and its progress. And you see that OpenWrt and the code that actually makes the stack that runs on the device is only one of those blocks. There's a lot more than we do. And I've put them all in the same size here. You can, hopefully next year, I'll be able to show you what the difference in effort actually is. And I'm quite sure that the effort on embedded development is not the biggest out of those 6. Because one important aspect that we very often forget, and that's why I asked that question to the panel just now, is that the alignment, the consolidation of requirements between ISPs is fundamental to make prplWrt happen. Because otherwise, we have one stack that we all, as vendors, use and take forward, but then we have 27 different RFQ documents that come from different ISPs with a slight difference here, slight difference there, and at the end, we still have to fragment just because those requirements are not aligned. So that is a very important part, and is a lot more difficult than I had anticipated 12 months ago. Another one then is the CPE-focused features, where it's taken us quite some time, I think, and a lot of conversation and discussion to figure out how what we do as the industry actually fits into the model, into a delivery model that is based on OpenWrt. So how do you actually build the right feeds? How do you build the right target feeds? The integration, how can you actually align and very flexibly then build images for different targets or for different audiences or different customers? That has now been somewhat settled, and we have the first examples that we now can go ahead and document. I'm just going to claim that what we do was we decided to first implement and then write down the standard after, because we like to be fast, agile, and break things before we document them. That's actually not the case. We just have not spent the time of documenting it, or to document it, something that we definitely have to pick up. The fourth one here is Sdk and Tools. That's more what, that's probably easiest to understand if you actually go ahead and build images and build images for various customers. Then you find that what you have right now with most of the build tools is they're not designed for large teams. They're not designed for large customer or large collections of customers, and it's sometimes difficult to actually maintain them and all of that. We had a very good look at that, and we looked at different suppliers of software stacks to also align the requirements there and try and harmonize which tool sets and tool chains to use. So that's in progress. And then a big one, at least I think I speak for everyone here, a big one is the chipset integration. So how do we actually make all of the software run on software that comes directly from the chipset vendor, so that we don't have to maintain, each of the company doesn't have to maintain integration on chipsets. And that is also a lot of effort, which does at the end of the day not produce a lot of lines of code. And the last one, and I'm very happy that that also came up in the panel, that also gets forgotten very, very often, is quality assurance and testing. Something that we strive for, and I think we've made considerable progress over the last 6 weeks to actually align on how we do testing. What does that actually mean when we say we want to test a software stack? Which aspects do we want to test? Who takes responsibility for testing which parts of the stack? And how can we ensure that if you develop a device, a highly differentiated device and product proposition, that you can test that, you can use the same test setup without having to give anyone your secret and differentiated device? That is not an easy problem to solve. I'm very, very happy that we have a lot of technically very, very capable people involved in prplWrt. That is the vendors, that's the help that we get from the OpenWrt community, also based on their experience working with different suppliers, the requirements that come in from the ISPs. All of those have led to what I think is a very vibrant and very active project, but it is not about lines of code. So if you want to evaluate what we actually do, it is more than just looking at the lines of code. So my ask is you bear with us a little bit longer. Some of us are just getting a bit more time to actually document all of these things and then come back, read the documents, understand where we're taking this, where we're trying to harmonize between the different suppliers and approaches, and then we can also count lines of code. That was my little prayer here. Sukru, if you want to come up and tell me how to hook up those devices in which order, then let's see what Alex asks. Yeah? If we have picked a reference device for prplWrt. Okay, sorry. Awesome question. Thank you very much, because of course my body is still working on lunch. We have actually released an image for the RAX40, which is a commercial device by Netgear, and you can compile the whole prplWrt image out of the prplWrt GitLab. I believe if the open source gods are with us, even with a Wi-Fi driver completely open, that you can compile the whole image and you can run it, and it is just a vanilla OpenWrt 1907. I don't sell Netgear devices, so I'm not entirely sure. I believe it is $199 US. So it is a relatively high-end device. Or actually, for the consumer, it's a high-end device. It is that because it is based on an Intel chipset. So we had access to all of that with the great help and support of the Intel team. But there are also other devices that we work on, other devices and platforms, but that one is the first, so thank you very much for that question. And we actually do have a unit over there. RAX40. Yeah, you can find that also on the GitLab. I'll make sure to put the URL also in the slides, that you can actually go to the GitLab. There's a getting started, and it has a link to the device and device name. My question was actually when Sukru said, how about we demonstrate something? I was like, how do you demonstrate an embedded software stack? But he's gonna pull it off, so.
We are ready.
We're ready, awesome. Then how about, do you want to say something about your demo?
Okay. So what we are going to demonstrate is that, as Mirko explained last year in Prpl WRT, we were able to show that we got DSL up and running, and then multicast streaming, and then WebUI on Prpl WRT platform on an Intel-based device. Now we will show the progress that's which we already told earlier, that now in Prpl WRT we have integrated USP support as well. And thanks to BBF and Comscope, both sharing open source agent and also providing us access with the controller so that we could actually both verify our integration and demo it here today. So this is the Prpl Juicy API with Prpl WRT team, but what I will actually do is go to the other browser where we will show the USB controller. So this is the USB controller from Aris, which now I actually, among the agents, I selected the agent that this device is connected to, and then I will go to run workflow and then run a couple of the USB commands to show the support. Of course, it's going to be a bit boring maybe because I will have to actually type some parameters. Let's see. We can start with a get parameter, for example. I can do that. Could you do? I'm not good with Mac. Okay, perfect. So here, let's start. Could you actually hold this for me?
Okay.
Let's start with device.by .ssid.1.ssd. The connection is a bit slow, so it might take time. So simply now you can say that we got the first SID of the device, which is on 2.4 frequency. Here, there is the support on regular expression on USB as well, which we could show, but it's going to be more difficult for me to type some kind of regular expression, so I will pass that part quickly and actually try to change something here. I have to check.
Do you want to check the other name, the current SSID name first?
Yes, actually, that's a good point. Can you switch to the other browser? Yeah. Okay, so now you can see on the topology map is that, actually, if you could scroll a bit up or down, so it's going to be easier to show. So now the 2.4 SID is iopsys Prpl 2.4. So what I'm going to, now this is, as in the previous diagram that I showed, they are both built on top of OpenWRT UBus UCI APIs, both the WebUI and the USB. Now I'm going to change it through this UCI object of the UBus and on the, through USB, and then it's going to affect, you will see how it affects the WebUI. Okay. again quickly. Okay. device.wi-fi.sid. That's one. Yes. I don't need this one. And then Prpl SSID. Okay, now I managed to change it. If we 1 second, I actually need to, you already connected to that, I think. I need to check, because I changed the SID that you were connected to. Now I need to connect to back. Can you go to the Wi-Fi? Okay, you are connected, good. Now if you go to the browser again, now you see that on this topology map, you see that now it's actually changed to purple. If you quickly reload the page by refreshing. Okay. So it might not look all exciting, of course, but at least now on prplWrt, now we try to prove that we have USP support, we have a API, they are built on top of the OpenWRT's UBus APIs, and hooking up to the same parameters underneath. And you have a JavaScript-based API support and USP support today on OpenWRT, prplWrt. So, as I said, a lot of these parameters are mapped, about 50–60% of is mapped to OpenWRT default APIs, UBus and user APIs. Rest is the vendor extensions, with some of them prplWrt extensions, and some of them here you see from the iopsys extensions. But once we have agreed on the APIs, which APIs to use on this platform, then once it moves on top of it, it's going to be 100% working on prplWrt. So you can easily pick these components and put on top of your high-level API supporting platform. But I think I could actually quickly show one more thing. If you hold this. Can you come to the
browser? Yeah.
So a nice ending to demo by rebooting the box with a operate command, which is a new support in USB. Not this reboots part. You could do some other kind of calls as well, but I will try to conclude with this one. Let's see how that works. I will check now if it is rebooting. No? Then I have to check if I wrote the command correctly. Okay, could you, okay, here it is. Let me remove this extra ones. And then, okay, now it's rebooting. If you go to other browser, yeah. I don't need to show that we lost connection to the box, but so at least we try to demonstrate get, set, and reboot. So USB support on Prpl. Any questions on
Okay.
specific?
Yeah, the exciting thing here obviously is that would now work on, or actually does, not just would, but it does work on any box that uses prplWrt, so all of the 6 boxes that I was showing earlier. And this is available, and then you could run it on your own devices in your own labs. And of course, you can imagine something far more complex than this, like a container implementation or a security solution or anything of that sort. So once it does run on the reference device, like the RX40 in that framework, it is available and works on every other vendor's device, and that is actually the power that we want to show. So what we have in terms of demos are devices from different vendors that use the same base software stack that comes out of the GitLab, but then have their own vendor flavors on top, but you can actually exchange. If it's the same architecture, obviously you can exchange packages, otherwise it gets a bit more, you have to recompile, but you do not have to change the code itself. And we have that in the, where we had food, right? Where we had lunch?
Yes,
yeah.
we had lunch, there's iX40, that's
okay.